So far, the field of trigonometry that we're studying right now is called right triangle trigonometry because we're dealing with right triangles and also with angles less than 90 degrees. Because if you notice in a right triangle, all the angles are either 90 or less than 90. So therefore, we call this area of trigonometry right triangle trigonometry. We will be touching up on non-right triangle trigonometry in future videos. So in this video, I want to discuss the two special triangles. And these are called the special triangles because they include three of the most important angles that we've dealt with. If you remember in previous videos, I had mentioned how important the angles 30 degrees, 45 degrees, and 60 degrees are. These are very important angles, and there are two right triangles that include these angles in them. And it's actually very important to understand them and memorize them. The first triangle is called the 45-45-90 triangle. Or in radians, you could say it's the pi over 4, pi over 4, pi over 2 radian triangle. Okay? Because these angles, they could also be given in radians. Okay? And if you remember, pi over 4 is 45 degrees radians. So if you remember in geometry, when you have a triangle, the smallest side corresponds with the smallest angle, and the biggest side corresponds with the biggest angle. So because this has two 45-degree angles, that means both the legs, both their corresponding sides, or the sides opposite to them, are exactly the same. So let's say that this side is A and this side is A. They have to be the same size because they have the same corresponding angle. They have the same opposite angle. Therefore, what would that make the hypotenuse? Well, using Pythagoras' theorem, a squared plus a squared has to be equal to the hypotenuse squared. Correct? So that means then that 2a squared is equal to h squared. So h is equal to square root of 2a squared, which simplifies to a square root of 2. And there we have it. Now, personally, I don't like to memorize this specific order of sides. In my opinion, the best way to memorize this right triangle is with the sides one, square root of 2. You see, if you make a equal to 1, we end up getting this triangle. And this is the simplest version of this triangle to memorize. Now, of course, we can expand or shrink this right triangle by multiplying all sides by the same amount. And this is essentially what this right triangle is showing us here. A is just the multiplier. If you multiply by 2 and you make a equal to 2, therefore this triangle would double in size. But at the end of the day, when we're working with trig functions, all that matters is a ratio. I'll prove it to you. If you notice here, you could say that these two triangles are similar triangles. But again, the first one is a little bit easier to memorize. So let's prove it here. Let's say we wanted to find sine of 45 degrees. Okay? Well, because both the angles are 45, it actually doesn't matter which of them you choose. You're going to get the same ratio regardless. So sine is opposite over hypotenuse. So in this case, we're going to get 1 over square root of 2. Notice if we did the same thing with the similar triangle and we wanted to find sine of 45, we would get a over a square root of 2. Notice this just simplifies to 1 over square root of 2. we end up getting the same exact ratio. So, because again, all that A represents here is what you can multiply or divide by to get a similar right triangle. But at the end of the day, I would highly recommend that you memorize the sides 1, 1, square root of 2. Those are the smallest and simplest sides you can have in this right triangle. And you will obtain the same exact ratio. Now let's take, for example, cosine 45. Cosine is adjacent over hypotenuse, so it's going to be 1 over square root of 2. 45 degrees, if you notice, is the only angle where sine and cosine is exactly the same. And last but not least, let's go ahead and find tangent of 45. Well, tangent of 45 is opposite over adjacent, so 1 over 1, or 1. So tangent 45 degrees will always be equal to 1. And of course, the reciprocal functions, cosecant, secant, and cotangent, are just the reciprocals of sine, cosine, and tangent. Now, the other triangle we're going to deal with includes the angles 30 and 60. Because if you think about it, 30 and 60 are complementary angles, so of course they can both exist in the same right triangle. So I do want to dissect where this triangle comes from. So let's say, for example, we have an equilateral triangle like this. If you remember, an equilateral triangle has all degrees equal to 60 degrees. And let's say that all the sides were a length of 2. So if we wanted to cut this equilateral triangle in half, notice we end up with a right triangle here. This angle, so let's go ahead and draw it over here. This angle here stays 60 degrees. This angle here was cut in half, so that's 30 degrees. And here we have a 90 degree. So notice the 30, 60, 90. This side here was cut in half, so we have 1. This side is still 2. And then if we want to find the missing side, we can use Pythagoras' theorem. And you end up figuring out that this side is equal to square root of 3. Therefore, the second special right triangle is called the 30, 60, 90 triangle, or the pi over 6, pi over 3, pi over 2 radian triangle. Because again, if you wanted to represent these angles in radians, they would be pi over 6, pi over 3, and pi over 2. So this here is, again, the simplest numbers we can use to represent this right triangle. Of course, if we wanted to find a similar right triangle, we can multiply or divide all sides by the same amount. So alternatively, you can memorize 2a, a square root of 3. These two triangles are similar triangles, where the one in green represents a triangle of any size, where you can multiply or divide by a, and you'll get a similar triangle. However, again, when dealing with ratios, the size of the triangle doesn't matter. You're still going to get the same ratio. So it's best to just memorize the simplest version of the 30, 60, 90 right triangle. So let's say we wanted to find sine of 30 degrees. Well, sine of 30 degrees is opposite over hypotenuse, so that would be 1 over 2. Alternatively, sine of 60 would be square root of 3 over 2. How about now cosine of 30? Cosine of 30 would be adjacent over hypotenuse, so square root of 3 over 2. And alternatively, cosine of 60 would be 1 over 2. And finally, tangent of 30 would be opposite over adjacent, so 1 over square root of 3. And finally, tangent 60 degrees would be square root of 3 over 1, or just square root of 3. And then, of course, the reciprocal trig functions, cosecant, secant, and cotangent, would just be the reciprocals of the three main trig functions. So, to wrap this video up, here are the two special right triangles. You are expected to know and memorize these two special right triangles because 30, 60, and 45 are very important angles that show up many times in trigonometry. So knowing these right triangles will help you figure out the trig functions for the angles 30, 60, or 45 degrees. These are the simplest versions of the two special right triangles. Therefore, this would be the easiest way to memorize these two. I forgot to mention this, but one way to make the 30, 60, 90 triangle easy to memorize is remember, the smallest side corresponds to the smallest angle, the biggest side corresponds to the biggest angle, and the medium side corresponds to the medium angle. So in order, going from 30, 60 to 90 degrees, 30 degrees is the smallest angle, therefore opposite to it is the smallest side, 1. 90 degrees is the biggest angle, therefore opposite to 90 degrees is the biggest side, 2. And 60 degrees is the middle angle, therefore it's opposite the middle side, square root of 3, which is approximately 1.732. So of course that is the middle side. So that should make it easier to memorize the order in which the sides correspond to the angles. So, to wrap this video up, answer these 4 trig functions using the special right triangles above. So pause this video, try to do these on your own, and when you press play again, the answers will show up in a few seconds. And there you have it. These are the answers. So before you end the video, just remember, memorize these two special right triangles because with them, you can find all 6 trig functions for the 3 special angles 30, 60, and 45 degrees. Good luck. See you guys later. Bye.